Hello, everyone. Thank you for joining this webinar today. My name is Manu Parimi. I'm an applications engineer here at Plexim. I'll go through the updates and new features in the latest Plex release, version 4.2, which was released a few weeks ago. If you haven't downloaded it, you should go to plexim.com and download the new version. Okay, so I'll show some improvements to schematic design in Plex, what is possible to do via scripting, and updates to the Plex Coder and Plex Processor in the Loop or Plex Pill today. We will keep the webinar to approximately 30 minutes today. Please feel free to send us questions during the presentation using the questions window on the GoToWebinar control panel. We'll try to answer when appropriate or at the end. With that, let me provide a brief background on our company and a framework for what we are going to discuss today. We are originally a Swiss company. We were founded in Zurich, Switzerland. We started in 2002 with Plex, and more recently we've developed RTBox, our real-time platform for hardware in the loop simulations and rapid control prototyping. We have offices in Zurich, Switzerland, and in the US, we have offices here in Cambridge, Massachusetts, and in Seattle, Washington, in the West Coast. We have customers both in universities as well as industries. All right, so here is the list of the features that I'll be showing you today. I'll discuss each of these items separately. The first major update that I want to talk about that we expect the largest percentage of users will benefit from is our new routing algorithm and auto connect feature in the schematic editor. So let me demonstrate that. From your Plex library browser, open a new model. Okay, so let's say you want to build a motor drive from a DC source and a converter. So let me choose the DC source and an IGBT converter here, and maybe machine. Okay, so let me flip that. So previously you really had to connect all the components individually, and in some cases multiple connections per component. Now you can simply click on a component and preview suitable connections by pressing the Alt or Option key on your keyboard, and the mouse is hovering over a compatible component. Now, still holding down the Alt or Option key, click on the second component, like so. Now, once I let go, you can see the DC terminals of the inverter subsystem have been interfaced to the DC source. Similarly, you can even draw multiple connections at once using the same technique. Now I'm clicking on the converter and I'm holding the Alt or Option key, or on your Windows and Option on your Mac, and then selecting the machine component. Now again, I'll click on the component. You can see the connections are automatically made. So while it does this, it takes care to avoid overlapping wires. So you can see now these nice bends here. You can also do the same thing with connections between multiple components. So for example, if I had an ammeter, like so, and you might want to multiplex all the current measurements into a vectorized signal. So I'll take a multiplexer block. Okay. So now what we can do is select all the ammeters, and again, holding down the Alt or Option key, I point to the multiplexer block, and there you go. You can make these connections easily. Also, the routing algorithm will take care to keep nice connections when you reroute existing connections. So what I mean by that is, for example, if I move this component like that, you can see that it's maintaining the bends. It's maintaining the bends. That's because it doesn't want to touch these existing connections. So it tries to make new connections without touching the existing connections. But if you want to clean this all up, what you can do rather than dealing with individual links or individual connections is select the components and go to the file menu here and go to edit and select reroute selected connections. Then it reroutes the connections for you like that. Okay, now you can also connect components with different number of terminals. For example, if you want to connect a component with 3 terminals to the one with 4, the first 3 terminals will be used and the last one will remain unconnected. For example, let's take a scope block and let me move these things a little here. Okay, so for example, if I had 4 plots like that, let me remove this. And now again, I'll select the ammeters and hold down the Option key and point to the scope component. You can see now the first 3 terminals are connected and the 4th one is not. Okay. You can also connect multiple components to one component even if it only has one terminal. So for example, let's say we have a sine wave generator and we want to connect this to 3 controlled voltage sources. So you might want to do this because you want to vectorize the output of the sine wave. And then if you want to offset these 3 phases by 120 degrees, you may want to do this. Now what you can do is you can select the 3 control sources and again hold down the Option or Alt key and again point at the sine wave. So the connections are automatically made. Similarly, if you had maybe 3 resistors like so, and you want to parallel these 3 resistors with a 4th resistor, then what you would do is you can select the first 3 and hold down the Option key and point at the 4th resistor to make new connections. Okay, so it is also now possible to drag more than one connection segment at once. So for example, if we had something like this and we select this vertical components, now we can choose these segments and drag them all together to left or right. This will move one segment of every selected connection, always the one closest to the mouse, like so. Okay, this is a really neat feature and we invite you to experiment and see what's possible with the auto connecting and signal routing features. You can also read about this more in our user manual and built-in online help here. So if you go to help and Plex documentation, this would be under online help and using Plex connections. So this is where you'll find about these new connections. All right. Okay, so moving on in our list, let's discuss the dynamic subsystem mask, icons, and dialogues. Up until now, you could mask a subsystem to make it look like a built-in or custom component, but the look of it and its block parameters were fixed. With these new changes, what you can do is, let me open up one of our new demo models that demonstrates that here. Okay, so this is a multi-phase buck converter where the power stage uses multiple buck converters in parallel to reduce the ripple of the output current. In this example, you can change the number of phases using this parameter, and the component icon will change to reflect the system being implemented underneath the mask. So for example, you see the model uses 2 phases by default, which we see in the image here. Now if we change this to 3, you can see a third converter is displayed. The same is true for 4. And also for 5 or more phases, we see a new icon like that, which basically represents that there are more phases that can be drawn here, essentially. Okay, so similarly, we also have a dynamic mask dialog. So for instance, if I double click here, we have a dead time parameter. You can turn the dead time on or off. When you switch the dead time on, you can see the duration parameter here. But when I turn it off, you see the duration parameter disappears. Same is true if I turn it on and check these boxes and click apply. You can see them here on the schematic. So if I turn them off, you can see that the duration parameter disappears. So this is the new dialog that we have implemented. The way the dynamic mask icon here that I've shown previously and the dialog are configured is using a new scripting extension called Lua, which we have now embedded into Plex. Now to view that, you right click on the subsystem and go to edit mask. Now this is the mask editor. You can see the icon tab. Here are the drawing commands in the mask editor for this dynamic mask icon. We are using the Lua language. What you can do here is implement conditionals or define local functions and use these local functions here to draw nodes and simplify the drawing effort. If you see this icon, for 4 phases, now there are a lot of lines. And to do this individually would require quite some effort. Now the drawing commands themselves have also been extended to include the ability to draw arcs, for example. We only had circles before. Now these arcs can be used in this instance to draw these inductors easily. Okay, so this summarizes the new drawing commands. The dialog callbacks are found in the next tab, and the way the dynamic behavior is achieved is by getting the current value of a certain parameter, in this case, the dt state variable. And if this is not off or the index corresponding to 1, this parameter will be visible. So t dead, which was the duration of the dead time, will be visible. Here you can use all kinds of language constructs that the Lua language supports. For example, we could change the visible here to enable. So let me change that to enable and click apply. So now if I double click on my subsystem, you can see that when the dead time is off, the dead time duration is disabled, but it's still visible. But if you change that back to visible, that would totally disappear. Okay, so if you're interested in more details, you can of course always click the help button to access the built-in online help to see the description of this feature and where it's applicable. All right, so I'm gonna close that. The next item on our list is scripting for scope export. This allows for generating images and exporting data for more convenient reporting and post-processing. You can also get the cursor readings from a script. So let me show that. Here we have pre-built a model. So the scripting can be accessed by simulation scripts. So Plex 4.2 now has scripting commands for these purposes. There is an export CSV command to export all of the data to a CSV file or to export a bitmap image file of the scope output. Both of these commands are included in this example script. So when I click run, you can see the CSV file and an image file is generated here in this folder. Let me open that up. So this is the scope, and that's the data file. All right. Again, you can always access the help button here to learn about it. And if you're interested, you can customize the image file even more, such as to override the size or the resolution, or if you want to add title, legend, add custom labels, etc. We can try to do that now. So let's say, for example, to this scope, I want to add a legend position. So I can maybe copy that from here and paste it. Maybe I want to add my legend position to the top left. So I say top left and then click accept and run. So now you'll see that in the scope file, we have this legend on the top left. The third main benefit of the new scripting commands is that we now have access to the cursor data, directly allowing for access to the built-in scope analysis rather than needing to do everything in a post-processing fashion. So you can see that in these next few lines of code, we can read maximum, average, that is the mean values for all signals of all plots of the scope. And we can also print them in our console. Let me run, and maybe I'll open up the scope window, and you can see that the maximum and minimum values are here. But if I go to the console, you can also read the same values here. So the maximum value here and the mean value here. Okay. Oh, by the way, all of these new features that I'm showing on Plex standalone are also possible for Plex block set users via MATLAB scripts and the command line. Okay, let me close that and go back here. Okay, so the next major feature of Plex 4.2 is that in the Plex Coder, which is an add-on to Plex. So if you want Plex Coder, you can always request us for a trial and we can send you a trial if you want to play with that. Right now, what we can do is we can support data types other than floating point with this new version. We have only supported floating point until now. Now we can support other data types as well. For example, now we have Boolean data types and integer data types that are mostly used automatically. What I mean by this is, let's say I had a relational operator block, then the output would be Boolean automatically. The output data type is automatically Boolean here. Other blocks such as signal generators or the pulse generator block here allow you to specify basically the data type that's going to be used. So if I double click here, there's a new coder tab. So you can specify the output data type. So you can choose anything here, but if you don't choose anything, then the previously used target default will be used. Okay, so I won't demonstrate this further because it's a bit more expansive of a topic. But again, like I mentioned, if anyone is interested in testing this out, you can contact us to request a trial license of the Plex Coder. Okay, so continuing down the list, a technical improvement has also been made to Plex processor in the loop. With Plex Pill, you can run a co-simulation of an embedded control target with the Plex model of a plant for safe and efficient software development and regression testing. So this improvement now with 4.2 includes support for JTAG communication channel. It is less efficient than a traditional serial communication link, but it can also be easier to set up. Again, like with the Plex Coder, like I mentioned before, Plex Processor in the Loop is an add-on, and a trial license for this tool can also be requested by contacting us directly. Finally, several new demo models have been added to the library built into Plex. This includes the multi-phase synchronous buck converter that I showed you briefly before. And let me actually go back here. The way you can access demo models is by going to Window, Demo Models. And to see what's new in 4.2, you can choose New in 4.2, like so. You can see that the multi-phase synchronous buck converter that I showed you before. And there's a dual active bridge converter with loss profiles for silicon carbide MOSFETs. We are using Wolfspeed MOSFETs here, and we also have a two-stage LED driver with a nonlinear LED load. I really encourage you to explore these, and we've also updated some of our old demo models as well. All right, so that concludes our overview of the new features included with Plex 4.2. Thank you again for attending the webinar today, and have a great day.